I wanted to spend some time talking about what is going on in this random variable trickery worksheet. We started talking about it in class, and I wanted to elaborate more since we ran out of time. If I go too fast, remember that's the beauty of a video. You can pause it, you can think about what I said, you can zoom in on some of my notes, and always ask questions if you still have questions at the end of this. So we're looking at this scenario here. So X equals the number of credit assessment points earned if you would spin this spinner. It has 4 sections. 3 sections give you 0 points, and then a quarter of it gives you 1 point. So here's the original distribution for X. Okay, I have my first outcome, which is 0. There's a 3/4 chance of that. And then an outcome of 1 extra credit point, and there's a 1/4 chance of that. To find the mean, remember these are formulas on your formula sheet on the AP test. I take the possible outcome, which is 0, times its probability, plus my next possible outcome times its probability, which gives me an expected value or a mean for this random variable, 0.25. To find my standard deviation, I start by finding the variance. This is really important for this unit that you understand the variance is just the standard deviation squared. So I take each value minus the mean, square it. It's the average distance from the mean times the probability. Again, this formula is given to you on your formula sheet. I calculate that and I get 0.1875. So then my standard deviation for this game of extra credit is 0.4330 approximately, once I take the square root of the variance. So now we're going to say, well, what if we play this game, but instead of just 0, 1 points, we double the points? That would be 2 to X. So let's see what happens to our distribution when we double instead of just playing for 1 point. Notice my first outcome stays the same. It's still 0, and there's still a 3/4 chance of getting a 0. But now I can get 2 points, and there's a 1/4 chance of getting 2 points. So I calculate my mean. Same idea, 0 times 3/4 plus 2 times 1/4, and that gets a mean of 0.5. My standard deviation, same idea. I take each value, subtract the mean, square that, and then multiply by its probability, and I get a variance of 0.75, which is a standard deviation of approximately 0.8660. So that's if we double the points. Well, what if instead of doubling the points on the original game, I say, all right, you can spin the spinner 2 times. You get 2 chances. Now what happens when I do that, and I've got a tree diagram to model this, and feel free to pause this so you can look at it, is instead of 2 outcomes, there's actually 4 possible outcomes. I could spin it once, get a 0, second time get a 0. I could spin it the first time and get a 0, and then get 1 point on the second spin. So we have 4 different outcomes, and so on the probability table I'm about to show you, this is the probability breakdown for each outcome. So let's look at, and again, if you need to pause it, pause it. Here is the distribution for playing this twice. So if I play this game twice, then I get either an outcome of 0 points or an outcome of 1 point, and then an outcome of 2 points, and the probability breakdown is below. So your average for rolling this or spinning the spinner twice still ends up being 0.5. But notice our variation and our variance changes. My variance is 0.375, and my standard deviation is 0.6124. So let's look at the difference between these. Okay, so here we have here's my original mean, 0.25, 0.433 for the standard deviation. For 2 times our original variable, random variable X, I got the mean of 0.5, which is just in fact 2 times the original mean. Remember, the original mean was 0.25. For the standard deviation, we got 0.8660. Well, that is just twice the original standard deviation. So the scale factor of 2 is just going to be a scale factor on the original mean and on the original standard deviation. Well, that's easy enough. But over here, it's not the same case. The mean is still 0.5, but our variance and our standard deviation are different. Okay, let's talk about why. Multiplying by 2 in statistics with random variables is not the same as x plus x. This doesn't mean I'm just adding x and I'm adding x like it did in algebra. It means I'm going through an event 2 times. I wasn't just spinning the spinner once, I was spinning it twice. And we can see that this made a big change in our probability distribution, because now I could have gotten 0 points, I could have gotten 1 point, which wasn't an option here, or I could have gotten 2 points. Our probability distribution totally changed here, okay? Unlike in this scenario. Notice the probabilities were still the same here. The only thing that changed was the scale factor in the numerator. That's not the case in this second scenario. But there still is a fast way to get this new standard deviation. And if you notice, this variance of 0.1875 and this variance of 0.375 is doubled. So here's the key to finding this standard deviation when you are adding random events or you're repeating a random event, like spinning the spinner twice. You can just take the square root, because it's standard deviation, this does say sigma, of the variance, the original variance, and add it to the variance. It has to be the variance, though. I have to add the variances. I can't just add the standard deviation twice. That's going to break laws of your order of operation, okay? So we have to square and then add them before I can undo the square root. And I'm going to talk more about that in my next video.